Hi, my name is Akinari Kimura, and for my my video assignment, I will be working on problem 15 from chapter 2.4 of week 2. So the problem states, sketch a possible graph of function f together with vertical asymptotes satisfying all the following conditions on closed interval 0 to 4. So here I have my x and y axis and all my condition that is listed here. And so the first condition states that f of 1 is equal to 0. This is pretty straightforward. It says that at x equals 1, which is over here, f of x is equal to 0. So like this. Our second condition states that f of 3 is undefined. So at x equals 3, over here, f of 3 is undefined. Right now, I'm not gonna draw anything because I am still not sure if this is a vertical asymptote or just a hole. But if we look at the third condition, we can see that it's indeed a hole. The third condition states that the limit as x approaches 3 of f of x is equal to 1. So we have a hole here at f of 3. It does not exist, but the limit approaches 1. And as of now, I'm not gonna draw anything over here because I am not sure of the behavior of f of x over here and over here. And so let's move on to our next condition, the fourth condition, which states that the limit as x approaches 0 from the right hand side of f of x is equal to negative infinity. And so as f of x approaches 0 from the right hand side, f of x approaches infinity along the y-axis, which is x equals 0. So x equals 0 is a vertical asymptote. So our fifth condition states that the limit as x approaches 2 of f of x is equal to infinity. Over here we notice that unlike condition 5 and 6, this limit is neither just a right or left hand limit, but it's the limit from both the right and left hand. So over here we have a vertical asymptote at x equals 2, and from both sides, the right and the left, it approaches infinity. Yep. So that's our fifth condition. And our last condition is the limit as x approaches 4 from the negative side of f of x, or the left hand side of f of x, is equal to infinity. So again, when we have infinity or negative infinity, we have a vertical asymptote. So we have another one over here at x equals 4, and it's positive infinity, so it goes right up again. So it's something like this. We are not exactly sure what happens over here, but we know that it's going to, as it approaches x equals 3, it's going to approach, f of x will approach 1, which we can see by this condition. Okay, so to review if we got all the conditions right, f of 1 is equal to 0. At 1, the function is equal to 0. So we got that one. F of 3 is undefined. we have a hole at f of 3, so we got that one too. The limit as x approaches 3 of f of x is equal to 1. The function approaches, as x approaches 3, the function approaches 1, so we got that one too. And the limit as x approaches 0 from the right hand side of f of x is equal to negative infinity. As x approaches 0 from the right hand side, f of x approaches negative infinity. So we got that one too. The limit as x approaches 2 of f of x equals infinity. So as x approaches 2, we approach infinity from the right and the left hand side. So we got that condition right too. And our final condition states that the limit as x approaches 4 from the left hand side of f of x is equal to infinity. And so we got our vertical asymptote. And as we approach x equals 4 from the left hand side, we approach infinity. So we got that condition right as well. And this may not be the exact f of x the author was looking for, but it definitely satisfies all the conditions listed in the problem. Thank you.